Now in the Assess for section 5, chapter 5, all I'm going to do are a few questions from the AQA style exam questions. All the others have been seen before in the foundation course, so you look at that yourself. But these ones have not been done, so I'm going to do them because there's something higher about them, so I'm going to go for it. Question 2 says, this is question 2, the diameter of a solid cylinder, so this is solid, is 9.2 centimeters. Straight away, radius equals, just grab my machine, 9.2 divided by 2. So when I see cylinders, I want to see R, I don't want to see D. So I've got 4.6 centimeters. That's bound to come in handy in a minute. The cylinder is 25 centimeters long. In other words, H equals 25. Height, I know it's lying down and rolling around the room. If you turn it up that way round, it'll be 25 centimeters high, and the radius is 4.6. Calculate the area of one of the ends. Okay. So area equals pi r squared. I told you I'd need it. So that's going to be 3.14 times radius, 4.6 squared. Get an answer? So 4.6 squared multiplied by 3.14 comes to 66.44 centimeters squares. Calculate the total surface area of your cylinder. Alright, well, my cylinder is composed of another circle at the back, and it sort of somehow joins to here, though it's not really I don't want to do it like a cuboid, but anyway, so circle there, circle at the back, and let's do total surface area. Now, this is part B. Both circular ends come to 66.44, and of course that's times 2, isn't it? So multiply them by 2, I've got 132.88 centimeters square for now. And now working up here. What about this curved surface? If you recall, if you've got a curved surface and you unwrap it, you have this part, when it gets wrapped around again, is the circumference of the circle. So that's 2 times pi times r, and of course that is the height across there as well, isn't it? So that's the height. So this part is going to be 2 pi r times h. So let's work this part out. 2 times 3.14 times the radius, which is 4.6, and the height of this cylinder, of course lying down inside, is still 25. Alright, so that comes to 2 times 3.14 times 4.6 the radius times 25 for the height is 722.2 centimeters squared. So total surface area is going to be the 722.2 for the curvy part plus the 132.88 for the ends, and let's just add it in. Add 132.88. Total 855.08, so it's approximately 855.1 centimeters square of surface. Alright, and that's the cylinder done. Next question is question 3. Right, so cuboid is made from centimeter cubes. The area of the base of the cuboid is 5 centimeter cubes. Great, I've got to draw this. So imagine the bottom looks a bit like that, and it goes 1, 2, 3, 4, 5. Okay, so here it is, going into 3 dimensions now. So if you can imagine this happening like that, so I've got 5 on the bottom, but the volume of the cuboid is 10 centimeters cubed. So guess what? I must have another layer of 5 sitting on top. So bless me, I've got to try and draw this thing. This is horrid. Anyway, I'm going to have a go. So I'm going to go, right, I've joined the ends, I've done that successfully, up and along and down, up and along, and I've lost myself now. Something like that, isn't it? Down, up, along, down, join. Alright, that's not bad. Come and allow that. And of course I can go down here as well and all the rest of it and make it look all beautiful. So it's getting really confusing. Anyway, Work out the surface area of the cuboid and state your units. Okay, well look, let me just draw what I've got now. I've tried to show you by a scrappy little picture that I've got 10 centimetre cubes. The bottom is 5 in terms of the base area. 1, 2, 3, 4, 5 squares touching the bottom. So forget all that now. I'll now draw you a box all by itself. I've established it's 10 centimetre cubed. So along the bottom it goes 5, and then it goes in 1 deep, 1, and across here it goes 2 high. It's so not to scale, but anyway. Right, so surface area is going to be, well, I've got, just join this up now to make it look like, there you go, cuboid. So at the front, let's get rid of that mess. At the front I've got a 5x2 face. I've got one at the back as well. So 5x2, and I've got 2 of them. Well, that comes to 20 centimetre square of surface. Here I've got a 2x1, 2 times 1, and of course I've got 1 here at the back as well, that one. So let's just double that up as well. Oh, I did the times twice. So that's going to be 4 centimetres square of surface, and I've got the top and the bottom, haven't I? So it's a 5x1 at the bottom and a 5x1 at the top. So 5x1, and I've got 2 of those as well, so that comes to 10 centimetre squares. So total surface area is going to be 34 centimetre squares. I can see that. 10 at the back, 10 at the front is 20. 5 and 5 is going to be 30. 1, 2, 3, 4. So even by counting you can do it, but I didn't want to do that. So question 4 on the other page now is the last question for the assess. It says the diagram shows a cube. There it is. The volume of the cube is 1,000 centimetres cubed. That's good. And the label covers half the area of the front of the cube. Calculate the area of the label and show you working. Okay, I think I will. Right, well, we've gone from volumes down to areas now. Now, listen, if the volume is 1,000 centimetres cubed, then the side of the cube is going to be the cube root of 1,000. Therefore, each side is 10 centimetres in length. So I've got a 10 here, I've got a 10 here, and I've got a 10 that goes into the page there, or into the screen. Alright, these are all centimetres, of course. So that's that. So I'm told that the label covers half the area of the front. So therefore, area of the front is going to be 10 by 10, which is 100 centimetres squares. And therefore, area of label is going to be half of that, and therefore 50 centimetres squares of space is taken up by the label. Alright, the cube contains water. Oh, here we go. So I've got a label and it's got water in it. How much more water, oh, English, be careful, how much more water is needed for the cube to be 3/4 full? Give your answer in litres. Alright then, so part B, 3/4 of 1,000, that's its volume, that's how much it can take, is going to be 750 centimetres cubed. Alright, now the cube contains 200 of water already, so how much more must I put in? Okay, so I've got 750, 3/4 full is what I want, and I want to take away the 200 that's already sitting there, therefore that's going to be 550 centimetres cubed needed. Sorry, I slipped a bit there. Needed. Question, do it again. How much more water is needed for the cube to be 3/4 full? Okay, so therefore I need an extra 550 centimetres cubed, but give my answer in litres. Great, I must now divide by 1,000 to get it into litres. I don't know why, this is less than 1,000, why should they even do that? Anyway, that's going to be 0.55 litres. Alright, and that question's done, and that's that. Alright, part 6, chapter 6 in a minute.